Hello friends, a very warm welcome to another discussion pertaining to CSAT examination. Today's topic is permutations and combinations. Of late, it has been observed that CSAT papers consist of at least one question on permutation and combination. So let us have a look at the basics and how to apply those concepts to solve these questions in minimal time with highest accuracy. Now, first of all, what are permutations? Permutations are sequential arrangements. So as to say, let us say we have four letters A, B, C and D. In how many ways can we arrange these four letters without repeating any letter in the sequence? So simply, you have four places to fill up and total number of options here that you have to fill in these blanks would be 4. So out of these 4, any one letter can fill the first place. That is, it could consist of A, B, C, D, any one of them. Now, one letter has already occupied the first position. The remaining are 3. So, the second position would be occupied by any 3. Now, 2 letters have occupied the first 2 positions. Remaining are 2. And out of these 2, any one will occupy the third position. So, for occupying the third position, now we have 2 options. So, one out of these 2 will occupy the third position. Remaining one would occupy the last position. So 4 into 3 into 2 into 1. That is, there are 24 ways of arranging these 4 letters all together in a sequence. Now let us talk about 3 letters, A, B, C. Let us see how many arrangements can we get of 3 letters. Well, you can have ABC or ACB, BCA or BAC, CAB or CBA. So in total, there should be 6 arrangements. And how do you solve this? Well, you have 3 positions to fill up. For the first position, you have 3 options, that is A, B, C, out of which anyone will fill up the first position. So, one out of these 3 letters will fill up the first position. Remaining are 2. Out of these 2 options, for the second position, one will be occupying this position, and the remaining one will occupy the third position. So 3 into 2 into 1, that is 6 ways. So you don't have to manually write all these arrangements in detail. Just imagine these are 24 ways for this question and you cannot waste your time writing down all these 24 arrangements. Now let us say that we are given A, B, C, D 4 letters and we have to find out in how many ways 2 letters can be arranged without repetition. So that means the total number of letters are 4. So for the first position, we have 4 options, A, B, C, D. Any one out of these 4 letters will fill up the first position. So one letter out of these 4 letters will occupy the first position. The remaining are 3. So we have 3 options to occupy the second position. So 4 into 3, there will be 12 combinations of 2 letters that can be formed from A, B, C and D. That is 4 letters. So here the sequence is very important. Kindly know this. So sequential arrangement is permutations. We do have a formula for this as well. That is NPR. So permutation is represented with the letter P. NPR is n factorial by n minus r factorial, where n represents the total options available and r will represent total options selected. So when we talk about permutations and combinations, we are basically talking about the number of ways of selections out of a given group of items and how many ways can we select the items. So let us talk about this question. We are given 4 letters A, B, C, D. So total number of options available to us are 4. We need to find out the permutations. And here in this question, we are taking all the 4 items at the same time. So this is 4P4. Because we have to select 4 items. So hence this becomes 4 factorial by 4 minus 4 factorial. Now what is a factorial? I will explain to you, but you can know for now that a 4 factorial would mean that you have to multiply 4 with one number less, that is 3, and then multiply 3 with one number less, that is 2, and then multiply 2 with one number less, that is 1. So it will end at 1. So 4 into 3 into 2 into 1, the reverse counting, and 4 minus 4 is 0 factorial. Now 0 factorial is equal to 1 only. So this is 24 divided by 1, So hence 24 will be your answer. And when we have a look at this question, wherein there are 4 options in total, A, B, C, D, and we have to select 2, then in that case, we get 4 as a total number of options. B, we have to select 2 at a time. That is AB, AC, AD, and so on. So this shall become 4 factorial by 4 minus 2 factorial, which is equal to 4 into 3 into 2 into 1. 4 minus 2 is 2. 2 factorial will become 2 into 1. These cancel. So 4 into 3 is what we are left with, which gives us the answer as 12. Now what are combinations? Combinations are the total number of arrangements in which sequence is not important. So what's the difference between permutations and combinations? In permutations, sequence is important, whereas in combinations, sequence is not important. Now this can be found out using this formula. NCR is equal to n factorial by r factorial into n minus r factorial. So let us talk about this example of ABCD, which means that we have 4 options and you have to select 2 letters. So in that case, n becomes equal to 4 and r becomes equal to 2. So this can be written as 4C2, which is 4 factorial by 2 factorial into 4 minus 2 factorial. This becomes 4 into 3 into 2 factorial by 2 factorial into 2 factorial. Now what is 2 factorial? 2 factorial is 2 into 1. So these 2 factorial will cancel. So 2 into 1 goes here. So 2 into 3, we have 6 ways of making the selection. Now why so? Because AB will be same as BA in case of combination, but in case of permutation, AB and BA will be different because these are 2 different sequences. In AB, A comes first and then comes B. In BA, B comes first, then A comes later. So here in this question, you saw that permutations, you saw that various ways in which these 4 letters can be arranged, taking 2 at a time would be 12, taking permutations into account, and various ways of selection of any 2 letters out of these 4 ABCD will be done in 6 ways. Now let me give you another example. Suppose we need to select the playing 11 for the Indian cricket team. So first we select 30 players from across the country. So the total options that we have are 30, from which we have to select 11 players. So selection of the playing 11 will be given by 30C11. Whereas if we have to select them in a particular order, we also want to find out the batting order. So in that case, batting order of playing 11 out of these 30 players shall be given by 30B11. So that is a difference. When we talk about the order or sequence, that is when we make use of permutations, so that the arrangements are made as per a sequence. Whereas if we just need to select 11 players out of 30, we are not bothered about the order in which they will play or they get selected, then in that case we will take up combinations. Then in that case we will use combinations. Alright, let's talk about factorial. 0 factorial is 1. Kindly remember this. In the previous slide also we saw this happening. 1 factorial is also 1. So these 2 are same values. 2 factorial is 2 into 1, that is equal to 2. You keep on counting in the reverse order of counting numbers and then keep on multiplying these numbers. So simply factorial can be written as n factorial equals n into n minus 1 into n minus 2 into n minus 3. Keep on reducing the numbers or keep on counting the numbers in reverse order of counting till you reach 1 and keep on multiplying them. So what will be 3 factorial? 3 into 2 into 1, which is 6. 4 factorial, 4 into 3 into 2 into 1, that is 24. This can also be written as 4 into 3 factorial. Now this you can see, 3 into 2 into 1. What is it? It is nothing but 3 factorial. 5 factorial. 5 into 4 into 3 into 2 into 1, which is 120. This can also be written as 5 into 4 factorial. It can be written as 5 into 4 into 3 factorial. Now let us have a look at some questions and try to understand this concept in a more clear way. The question which is given to us here is, from the 4 digits 1, 2, 3, 4, how many 2-digit numbers can be made without repeating a digit in the number? So first of all, the total options which are given to you here are 4. So n becomes equal to 4. And you have to select 2 digits only. So r here is 2. So if we use npr equals to n factorial by n minus r factorial, it becomes 4 factorial by 4 minus 2 factorial. That is 4 into 3 into 2 factorial by 2 factorial. These two cancel. So that is 12. Now, you can make use of this formula, but use a simple logic and you would be able to solve this question without committing any error. And I would prefer you to solve the question in this way. Let us say you have to select 2 digits out of total of 4 digits. So the first digit, so for the selection of the first digit, you have 4 options. Any one number out of 1, 2, 3, 4 will get filled here. And for the second position, now you're left with 3 options. So 4 into 3 directly you get 12. So you will be able to save this much of work. This is much more faster and more logical. Now look at the next question. With the given numbers 1, 2, 3, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7. These are 7 numbers in total. How many 3-digit numbers can be made in which a digit cannot be repeated, a digit can be repeated? So you want to find out 3-digit numbers in which digit cannot be repeated. So to occupy the first position, there are 7 options for you. Which are those 7 options? 1, 2, 3, 6, 7, 8, 9. Any one out of these numbers would occupy the first position. For the second position, now you are left with only 6 options because one option has already been fitted into the first position. So hence, out of 7, 1 fitted in the first position, you're left with 6 only. So similarly, for the last position, you are left with 5 options. So hence, this becomes 7 into 6 into 5. That is 42 into 5, which is nothing but 210. So there are 210 ways of making 3-digit numbers without repeating any digit from the given digits 1, 2, 3, 6, 7, 8, 9. But if would have been allowed to repeat a digit, that is to include 111, 222, 333, 666, 777, or 112, 112, 1 is getting repeated twice. So in such a case, to fill up the first place, you have 7 options. To fill up the second place, you again have 7 options because the digit can be repeated. And similarly, to fill up the last place, you again have 7 options. So 7 into 7 into 7 is 7 cube, which is nothing but 343. So 343 such numbers can be made. Now these will include 111, 222, 333, and so on. This will also include 112, 115, 556, and so on, or even 676, because numbers are allowed to be repeated. Next question, with the given digits 0, 1, 2, 3, 4, 5, 6, how many 3-digit numbers can be made in which no digit can be repeated, digits can be repeated? Now, whenever you are given certain digits and 0 happens to be one out of those digits, then you need to be a little careful. Now, you need 3-digit numbers where no digit can be repeated. And these are 7 digits which are given to you from 0 to 6. But in the first place, that is in the 100th place, you cannot fill digit 0. So out of these 7, one option is gone, that is 0 cannot be fitted into the 100th place or the first place from the left. So hence here you have only 6 options. 1, 2, 3, 4, 5, 6. Any out of these 6 numbers can be fitted into the first place. Now for this, 0 is allowed in 10th place, but you have already consumed or utilized 1 digit out of 1, 2, 3, 4, 5, 6 to fill up the 100th place. So 1 gone out of 7, so remaining are 6, which also includes the digit 0. So now 2 digits have been utilized to occupy the 100th place and the 10th place. So 2 gone out of 7, remaining are 5. So 6 into 6 into 5, that is 36 into 5. There are 180 such 3-digit numbers that can be made from the digits 0 to 6. Now what if digits can be repeated? Well, if digits can be repeated, anyhow in the 100th place we cannot have 0. So we have only 6 options to fill up the 100th place or the first place. For the second place, all 7 options are there with us from 0 to 6. And for units place also, all 7 options can be used. So you can have 600, you can have 500, you can have 300, 300, but you cannot have 067. That is not a 3-digit number. So 6 into 7 into 7, that is 6 into 49, that is 294. So there are 294 numbers that can be made from the digits 0 to 6, wherein a digit can be repeated. Here we can have 300, we can also have 303, and likewise. You can also have 555, you can also have 113 or 131, likewise. Look at this question. With the given digits 234056, now 0 has been included here, alright, and in total these are 6 digits. How many 3-digit numbers can be made which are greater than 400 without repetition of the digits? So again, you need 3-digit numbers, but you are not supposed to repeat any of the digits, and the number has to be greater than 400. So for this position, when you are given 234056 and you need a number which is greater than 400, you cannot fit 2, 3 and 0 in the hundreds place. The numbers must start with 400 something, 500 something, 600 something. These would be the numbers which would be greater than 400. So now we are left with only 3 options, 1, 2 and 3, 4, 5, 6. So these are the 3 options to fill in the 100th place. Now we have already utilized 1 digit out of these 6 digits. So we can have any out of the 5 digits which are remaining now. So 2 digits utilized in 100th place and the 10th place out of 6. So we have 4 options only for the units place. So what you have here is a 3 into 20, which is 60. So hence 60 such numbers can be formed with the help of these 6 digits which are given to us, and each of these numbers is going to be greater than 400. Now look at this one. With the given digits 1, 2, 3, 4, 5, 6, now there is no 0 in the given digits. How many 4-digit numbers can be made? Now these are 6 digits, that is n, and we have to select 4 digits. In such a way they are divisible by 5. Repetition of numbers is not allowed. And obviously these 4-digit numbers have to be formed only by using these 6 digits, 1, 2, 3, 4, 5, 6, not 7, not 8, not 9, not 0. So 4-digit numbers, if at all the number has to be divisible by 5, then what is the divisibility rule for 5? If the last digit of a number is a 0 or a 5, then that number becomes divisible by 5. So 5 is already given to us here. So for sure in the last place, that is in the units place, we must position the digit 5. So that means we have only one choice, that is digit 5, to fill in the units place. So 1 digit occupied here. Out of 6, 1 gone, so 5 digits remaining. So any out of those 5 digits will appear in the hundreds place. Any of the 5 digits will occupy the thousands place. Now any of the remaining 4 will occupy the hundreds place. Any out of the remaining 3 will occupy the tens place. So the number of such numbers, 4-digit numbers that can be formed, which are divisible by 5, will be 5 into 4, that is 20, into 3. So 60 such numbers can be made from the given digits, which are 4-digit numbers and divisible by 5. Now with the given digits 0, 1, 2, 3, 4, 5, 6. Now mind you, once again you have 0 here. So be careful. How many 4-digit numbers can be made which are divisible by 5? Repetition of numbers is not allowed. Now you will have to calculate it separately for 0 and 5, because if at all this is what you try, that for the last position or for the units place, we have 2 choices, 0 or 5. No, it does not happen like that, because when you have 0 here, then you can fill any of the numbers 1, 2, 3, 4, 5, 6. That means you have 6 options here. And when you have 5 here, you cannot have 6 options here, because 0 cannot be filled in here in the thousands place. So let us calculate it separately. So first, digit 5 is in the units place. In such a case, we have fixed digit 5 in the units place. So we have only one option here. So 1 digit has been utilized in the units place. So these are 0 to 6, so these are 7 numbers in all. So out of 7 digits from 0 to 6, digit 5 has been utilized in the units place. Now we are left with 6 digits. Which are those? 0, 1, 2, 3, 4 and 6. But then 0 cannot occupy the thousands place, or 0 cannot be the first digit. So hence we are left with only 5 options to fill up the thousands place. Now see, the digits which are given to you were 0, 1, 2, 3, 4, 5 and 6. Out of which 5 you have already utilized in the units place, and repetition is not allowed. It's given here. So we cannot have 5 in the thousands place. Now 0 cannot appear here. In the thousands place, you can't have a number 0, 6, 4, 5. So hence 1, 2, 3, 4, 5. These are the only 5 options which can fill up the first position, that is thousands place. So now 2 digits have been utilized. Digit 5 in the units place and digit 0 cannot be included in the first position. But some other digit from 1, 2, 3, 4 and 6 has been fitted here. So 2 digits gone. Remaining are again 5, because in hundreds place you can fill up any of the 5 numbers, because here 0 is allowed, and out of 1, 2, 3, 4, 6, what other digits will be utilized? So other 4 will remain. So 4 will remain from these 5, and 0 can be utilized in the hundreds place, so that makes it 5 digits as option to fill up the hundreds place. So now 3 digits have been utilized, 1 here, 1 here and 1 here out of 7. So 7 minus 3 is 4. So to fill up the tens place, we are left with 4 options. So 5 into 5 into 4 into 1 should give us 25 into 4, and that is 100 such 4-digit numbers can be formed from the given digits, which are divisible by 5 in such a way that 5 occupies the units place. Now let us have a look at the second way in which we can form a 4-digit number which is divisible by 5, and that would be if digit 0 occupies the units place. So digit 0 is in the units place. Let's have a look at how we are supposed to do this. 1, 2, 3, 4. So here we are fixing 0 in the units place. So there is only one option now to fill up the units place, and that is 0. So out of 7 digits which are given to us, we have already fixed the position of digit 0 in the units place. So out of remaining 6 digits, any one digit can occupy the thousands place, and out of the remaining 5, anyone can occupy the hundreds place, and out of remaining 4, anyone can occupy the tens place. So this shall become 6 into 5, that is 30, into 4, that is 120. So the total number of 4-digit numbers that can be formed from the digits 0 to 6 shall become 100 plus 120, that is 220, which will be divisible by 5. So in such kind of question wherein divisibility is in question and 0 is given and divisibility by 5 is necessary, in such a case you should do separate calculation, one for digit 5 in the units place and once for digit 0 in the units place. Now the question is, with the given digits 0, 1, 2, 3, 4, 5, 6. Now these are 7 digits and 0 is given to you. So 0 is one out of these 7 digits. How many 4-digit odd numbers, look at this, odd numbers can be made? Repetition of digits is not allowed. So let us have a look at this question. Now out of 0, 1, 2, 3, 4, 5 and 6, if we talk about odd numbers, we get 1, we get 3 and we get 5. So total 3 odd numbers are there. So to fill up the units place, we have only 3 options, 1, 3 and 5. So to fill up the last place, only 3 options are available to us. So out of these 7 digits, 1 will be utilized here. Also you know that 0 is one of the digits which are given to us, and 0 cannot occupy the thousands place or the first place. So 1 was utilized here. 1 digit out of 135 will occupy this position. These are digits, so 3 digits, and 0 cannot occupy the first position. So out of 7, 1 digit will occupy the units place and 0 cannot be there. So 7 minus 2, 5 digits available to us as an option to fill up the thousandth place. Now that means 1 more digit will be utilized here. So out of 7, 2 digits have been utilized. Now remaining will be 5 digits that can occupy the 100th place. Here 0 is allowed. And then in the 10th place, we have 4 digits as the options to fill up this position. So in total, we will get 5 into 5 into 4 into 3. So this is going to be 25 into 12, which is 300. So there can be 300 such 4-digit numbers, which would be odd numbers, that can be formed from the given digits from 0 to 6. Now look at the next one. With the given digits 0, 1, 2, 3, 4, 5, 6, again 7 digits are given to us and 0 is present. How many 4-digit even numbers can be made without repeating any digit in a number? So what is the definition of an even number? The digit in the units place must be 0 or a digit which is divisible by 2, that is 2, 4, 6, 8. So for 0 you will have to calculate separately. So let us take the first case, that is digit 0 occupies the units place. So we are talking about a 4-digit even number. Digit 0 has been fixed in the units place. So we have only one option here. So one option gone out of 7. So 6 remaining. So to fill up the thousands place, we have 6 options. To fill up the hundreds place, we have 5 digits available to us. These are 6 digits, 5 digits as option, 4 digits as an option. All right. Into 1 digit, which is nothing but 0. So what you get is a 6 into 5, that is 30 into 4, which means there are 120 such 4-digit even numbers which can be formed from the given digits whose last digit is 0. Let's take another case. Digits 2, 4 or 6 occupy the units place. Now for the units place, we have 3 options, which are those: digit 2, digit 4 or digit 6. So hence 3 digits available to us as an option here to fill up the units place. So one out of those will be utilized here. Now again we know that 0 cannot occupy the thousandth place. So 0 is gone. 1 digit occupies the units place. 2 digits gone. So hence we have provision of only 5 digits, out of which one will occupy the thousands place. Now similarly, to occupy the hundreds place, here 0 is allowed. So we again have 5 digits as an option which is available to us. Now which are those 5 digits? Well, out of 0, 1, 2, 3, 4, 5, 6, let us say that 6 occupied this position. Okay. Now 0 cannot occupy this position, so that is why we were left with only 1, 2, 3, 4, 5. This is an example. So here 1 occupies, let us say, this position, the unit space. So 1 is out, 6 is out. Now 0 can definitely occupy this position. So 1, 2, 3, 4 and 5. These are the 5 digits which are available to us as an option to fill up the hundreds place. Now another 1 will get utilized here. 1 has been utilized here. 3 digits have already occupied the 4 spaces. Now the leftover space, that is the tens place, we have 4 options. So what we get here is a 25 into 12. Once again, that is 300. Such 4-digit numbers can be formed from the given digits, which will be even numbers with either 2 or 4 or 6, but not 0 in the units place. So the total such numbers, even numbers that can be formed, shall become 420. That is 120 plus 300. So once again, I'm just reminding you, be careful when digit 0 is given to you and a question is asked wherein even numbers or divisible by 5, where for 0 there would be a different calculation altogether. Now this question says how many triangles can be made by joining the vertices of a hexagon. Now before you go to a hexagon, I would like to take up a square in front of you. Now it has 4 vertices. If you join the vertices here, then how many triangles can be made by joining the vertices of a hexagon? Now see, even this looks like a triangle, isn't it? So this is a triangle, but then this is not a vertex. Alright, so we will count only these 2. This is 1, this is 2, and apart from that, this is 3 and this is 4. Now simple way is, there are 1, 2, 3, 4 points here. So n equals to 4, out of which to form a triangle which consists of 3 points, the value of r becomes 3. So you apply NCR, that is 4 factorial by 3 factorial into 4 minus 3 factorial, which gives you 4 into 3 factorial by 3 factorial into 1 factorial. 1 factorial is 1 only, 3 factorial gets cancelled, so anyhow you will get 4 triangles. Now here it is asked the number of triangles that can be made by joining the vertices of a hexagon. So again, once again, we will apply NCR, that is equal to n factorial by r factorial into n minus r factorial, the formula. Now here the value of n will be 6 hexagon, and we are going to choose 3 points at a time to form a triangle because triangle is formed with 3 points. So it is 6 factorial by 3 factorial into 6 minus 3 factorial becomes 6 factorial by 3 factorial into 3 factorial. So this is 6 into 5 into 4 into 3 factorial by 3 factorial into 3 into 2 into 1. This 3 factorial in the denominator and the numerator cancels. 3 into 2 is 6. So 5 into 4 is what we are left with. So there are going to be 20 triangles which are formed by joining the vertices of a hexagon. Now, how many diagonals can be made by joining the vertices of a hexagon? Once again, I would take the example of a square. Now, there are only 2 diagonals, as you can see here. And there are 4 points, which are given to us here in a square. When we talk about a diagonal, it's a line which is formed by joining 2 points or 2 vertices. So n here equals 4 and r is going to be equal to 2 because we need only 2 points or 2 vertices to join to form a diagonal. Now what you see is 4c2, that is 4 factorial by 2 factorial into 2 factorial, that is 4 into 3 by 2 factorial or 2 into 1, because these 2 factorials will cancel in the numerator and denominator, so it becomes 2 here, so gives you the answer as 6, but you have only 2 diagonals. Now why is this variation? With this formula we should have got 6, but the number of diagonals is only 2 in a square. So what happened here? See here, randomly the sides which were formed in a square by joining 2 points, they also got included. That is, square is a 4-sided figure. So from this 6, which is nothing but it is the number of lines, if you remove 4 sides of a square, you get the remaining 2 lines which are the diagonals. So the point I'm trying to tell you, to make here is the formula to find out the answer for such kind of questions wherein you need to find out the number of diagonals in a polygon shall be NCR minus N. That is the number of sides which is given to you. Now we're talking about a hexagon here. So hexagon, you know, is a 6-sided figure. So the value of N here is 6. So basically we have to calculate 6C2 minus 6. Now this becomes 6 into 5 by 2 into 1. Because anyhow 6 minus 2 is 4 factorial, that would get cancelled. So what you can also do is, you should open N only R number of times. Please listen to me again. You should open N only R number of times. So we opened 6 only 2 times. See, 6 into 5. That's it. Or else, if you just want to get into details, then let it be 6 into 5 into 4 factorial by 2 factorial into 4 factorial. 4 is 6 minus 2 factorial. So anyhow, 4 factorials will cancel. So this cancels, goes by 3. So this is 15 minus 6, because a hexagon is a 6-sided figure. So you will get 9 number of diagonals which exist in a hexagon. Now there are 10 points lying on a plane wherein no 3 points lie in a straight line. So in a plane we can't have 3 points lying in a straight line. That's not accepted. But yes, something like this, but no 3 points should lie in the same line. So something like this. Now on this plane, how many straight lines can be made and how many triangles can be made? Well, straight lines are nothing but the shortest distance between 2 points. So if there are 10 points, we are selecting 2 points at a time. So 10C2. So we should get 10 into 9 by 2 into 1. So open N R number of times. So 10 I opened 2 number of times. That is 10 into 9. Only up to 2 numbers. Otherwise it would have become 10 into 9 into 8 factorial by 2 factorial into 8 factorial. 8 factorial would have got cancelled. So this gets cancelled here. So you can definitely have 45 lines here in total. But how many triangles can be made? Well, a triangle requires 3 points. And since in this question it is already mentioned that no 3 points lie in a straight line, so hence we require 10C3, that is 10 factorial by 3 factorial. 10C3, wherein we will open N R number of times. So 10 into 9 into 8 by 3 into 2 into 1, because 7 factorial will anyhow get cancelled. So 2 cancels 8 by 4. 3 cancels 9 by 3. So 10 into 3 into 4. 3 4s are 12 into 10. That is 120 triangles. Now in a bag there are 2 white balls, 3 black balls and 4 red balls. And how many ways can 3 balls be picked from this bag? Now when the question is asking you in how many ways can 3 balls be picked, it does not mention the color of these 3 balls. So the total number of balls here are 2 plus 3 plus 4, that is 9. So out of these 9 balls, you will pick up 3 balls. So 9C3 is the required combination. So 9 into 8 into 7 by 3 into 2 into 1 you need not do. So 3 into 3 and 2, this is 4. So what you get is a 3 into 4 into 7. That is 12 into 7. So there are 84 ways in which 3 balls can be picked out of these 9 balls. And nowhere it is given that there should be 1 white, 1 red and 1 green or something like that. So color combination here is not important. You pick up any 3 balls from 9 balls. So do not confuse it with colors. Alright, so these were certain questions based on permutations and combinations. Do remember the basics and practice hard. We will meet again in the discussion for another topic. Till then, I wish you all the best. Stay safe and thank you so much.